Okay, so welcome back. Welcome back to everybody that saw the introduction and has come back to see some of the development that's going to go into this little project, and also welcome to anybody that's come for the first time, because you're in luck, because the last video was about half hour of me talking, so I'm actually going to perhaps do a bit of work in this one. When I sort of thought about doing the YouTube videos, I didn't actually plan to do what a lot of people do when they show their tool acquisitions and whatnot for that week, because to be honest, I haven't really got enough time to do a tidy job on the videos that I want to do without sort of adding any more in. However, the reason that I'm sort of mentioning this is because I sort of come up with something a little bit special I thought you might like, and so I'm going to take a minute or two, no, not long, but just to show you. So here it is. I'm not sure how well you can see, but for anybody who knows this sort of machine tools and sort of thing, there's the logo on here. It's a bison part. Now, I saw it on eBay and it wasn't really getting a great deal of interest, so I thought I'd have a little punt at it. Anyway, turns out that I got it. So what we got is a very nice bison tool holder, brand spanking new. It's got a bit of muck on it, but it's just where the storage gunge is still on there. I haven't had a chance to wipe them off yet. So we got that, and just so you know, for this box I paid a little bit over 80 quid delivered, and I don't know what's that, sort of $120, $130, something like that. And it's a heavy box. It's about 12 kilos, with everything that's in there. So it was a pretty good deal. So of course the other part is this. Most of you will probably recognize it. It's a bison. 3-position quick change tool post. Now it's a T3, so it's pretty large, as you can see. I'll be honest, it's a little bit, it's sort of right on the limit for the lathe that's here, but to be honest, like I said, at 80 quid there was no way that I was going to let it go. Again, the actual tool post brand, it's brand spanking new. The anti-corrosion coating is still on there. It looks as though perhaps it's been in storage for a little bit, because there's a few sort of areas where it may be starting to rust, but I mean they'll clean off, no problem at all. So I did a little bit of investigation, because I didn't really know how much they are worth, and when I looked into it, the tool post itself is, and I mean with most places with a good discount, you're looking at around the £350–380 mark. So I mean that was a good deal. The tool holders themselves, I've seen these, I think the lowest I saw them for was 95 quid. So 80 quid delivered, bargain. That's the end of that. I just thought you might like to see it, because I was quite impressed by my little haul there. Okay, so most of you are ready for this this dragon tail development, which we're going to do. I'm going to run through really quickly a few different methods to do reducers or cones and segmented or lobster back bends, depending on what you call it. Pretty quickly. I'm not going to spend a lot of time on there, and then we'll get on to actually developing the tailor. What I will say is, before we start, is that although this is a working shop, and obviously we're covered by the same health and safety rules as anybody else is. There's two things actually happening. Obviously I'm working, I'm doing a job, performing a task, but I'm also trying to record a video, and sometimes I may do things that perhaps shall we say frowned upon, or maybe not approved safe working methods and whatnot, but it's purely because it needs to look presentable on the video, and plus I'm filming a video, so I'm stopping and I'm stopping the camera, and then I'm going back to it and I'm starting again. So you may see me, I may tack, without my shield down, I may do something without my gloves on I should be doing, so please, don't, it's certainly not a how-to video. You need to abide by whatever procedures or rules or whatever your company or your country or your local area has, and it's no good saying Andy Morse did it on YouTube, because like I said, it's sort of half of what gets done to make the video look watchable. Okay, so we'll clear this away now, and we'll get get some marking off tools out. I'm going to be marking off on a composite sheet. Now, I think the trade name is Durastone Glastic. It's very similar to sort of, fiberglass, very thin fiberglass, but it's flexible. It's sort of epoxy resin bonded, and it's only 0.8 of a mil thick, and it's better. It's a lot better than paper, to make patterns on. I mean, if you're doing perhaps some fabrication that's got to look good, is it perhaps having a natural finish or whatever, you don't want scribe marks on there, you don't want development marks on there. And I mean, this stuff is very good, because it doesn't burn, oil doesn't affect it, thinners don't affect it. You can blue it up if you need to see a bit clearer, and you scratch mark it the same as you do sheet. So I mean, it's one set of tools. Also, if you're a little bit unsure about your pattern, it's very good to form. It's got a bit of rigidity to it, and you can score it and fold it and whatnot, and it'll hold shape pretty well. It's also good if you're doing pipe bend development. For a standard size pipe, you can wrap it around the pipe, and mark it off that way, and it won't tear, it won't fall to pieces when it gets wet and stuff like that. It's great stuff. So that's what we're going to be using. I'm very lucky I get it donated by a company that I do a lot of work for, but if you can get hold of some, it's great stuff, it really is. Okay, right, let's get going. Okay, well, here we go. The bit that we've all been waiting for. I'm actually going to do a bit.
I'm going to get on to the actual dragon's tail in a minute, but firstly I just want to run very quickly through some simple development patterns that we can use for the different components of the actual tail. Now we've got two main components, and that's your reducer or your comb, and we've got the segmented bend or lobster back bend, depending on what you call it. Now there's a few ways that we can do them. What I'm going to do is I'm going to show you a few quick ways to do cones and bends, which don't actually work for the tail, but are handy bits of information to know if you're ever out on site where you're stuck anywhere, right? So very quickly, I'm not going to spend a lot of time on this because you're going to get bored. If you've got any questions or you want me to go a little bit more in depth into it, then drop me an email or put something in the comments, and perhaps we'll do something a bit more in depth into it. Right, we're going to start the comb. First thing we're going to do, you might see there's a few lines on this that I glued out. Basically I filmed this last night, and when I looked back over the video, it didn't really show up very well. The camera angles weren't very good, and it was quite difficult to sort of make out what was actually on the sheet. Now, the first thing I've done is I've just put a baseline onto the piece of glass stick. Like I said earlier, the reason I'm using glass stick is because it marks exactly the same as plate. It's the same tools, the same sort of techniques for marking, and like I said, you can form it to a certain degree if you want to check a pattern. Now what I've done is I've put a baseline on there, just something to work off. I've picked any point off there, and I've set my dividers at anything, doesn't matter. And I'm going to take my other set of dividers, now slightly bigger, from the 2 points that I just marked, which it doesn't matter where they are as long as they're swung off the centre point. And I'm going to swing an arc up there, and that's purely just to bisect this, so that I got two lines on here exactly perpendicular to each other. Okay, so I got a nice right angle to start with. I've got to start square, otherwise nothing's going to be square, it's all going to be off. I've left a little bit of room under my baseline, just in case I want to drop below that to do any marking off. Also, I've extended this line through as well in case I need that. Okay, so this is all stuff that you can do on site with a pair of dividers. You don't need any fancy plate squares. This is more accurate than plate square. To mark out, it's very easy to do. Look, I got next to no tools hardly here, and this is ample. In fact, it's probably too much. Okay, what I'm going to do, just for demonstration purposes, I'm going to pick any size reducer. I'm going to pick a nice small one that we can use this method for. So, say we're going to do a reducer from 100mm diameter down to 50mm diameter across 100mm. So nice simple dimensions. So what I'm going to do is from my centre line there, I'm going to mark off the radius. Yeah, so that's 50mm. If you notice, I started at the 50. You can start wherever you want. You can start at the 100 and mark 50. You can start at the 50 and mark 50. You can start at the 200 and mark 50. It's a little bit more accurate than starting at the end of the row. Yeah, same with the tape measure. Rather than working off the actual stop on the end, it's sometimes better off working off your 100. But you've got to be a little bit careful, because then you get that dreaded 100mm error if you count it wrong. Okay, so next thing I'm going to do, I'm going to mark off my height. Right, now I'm not being particularly fussy Yeah, I mean really, I should make sure that this dimension here is parallel to that. But to be honest, I mean for the tolerances that you'd be expected to achieve, you know, sort of on site, or even, you know, even in a workshop, you know, making this sort of stuff, it's going to be well within that. As you notice then, that's one of the issues with this sheet, is it's a woven fibre. So if you've got a very sharp stripe, sometimes it catches the fibres and you're off on one, you know. Right, next I'm going to just scribe off my smaller radius. Yeah? Then from my large radius then to my small radius, I'm going to put a line through. Straight through the centre line here. There. Right, now this point here, where they intersect, that's known as the apex. Yeah? Now, I mentioned in a previous video that this method only worked for a certain range of reducer. Now obviously, you know, the less that angle becomes, the less reduction that's in it, the further that apex is going to get away. Yeah? So I mean, you're probably all right with I mean, dividers are no good. These only open up to about 350, maybe 400. But you can get trammels, you know, that'll do 1 meter. I think anything bigger than that, you know, and they lose their accuracy, they're wobbling about, and it's just hard work. And there is another way of doing it. But we'll stick with this for a minute, and then we'll move on to the more suitable method. So what I'm going to do now is I'm going to set these dividers at the apex to the large radius. Yeah, just to check a minute. Yeah, okay. And I'll push that in slightly, and what I'll do is it'll cause a little indentation in the sheet so I can pick up on it when I swing my next arc. So okay, we swung an arc. Doesn't really matter again at this point how far you swing that arc. I always try and go, you know, a little bit past the centre line, because you know you've got enough. If you've got to put more in there after, you know, it's a bit of a nuisance. Now I've set it up to line up between the apex and my small radius, and I swung an arc. Okay, next thing we're going to do. The reason I'm swapping between dividers is because the larger dividers aren't so accurate on small diameters, and what's going to happen in a minute is we're going to, when we move on to a triangulation, we're going to leave one set at one set at one dimension, and we're not going to change it. Okay, so from my baseline center point, I'm going to swing my large diameter. Yeah. Now without altering my dividers, and I come to that point, I'll swing an arc that way. Then I'm going to come to the centre there, and I'm going to swing an arc that way. But I can follow this through if I wanted. Yeah, and swing it that way as well. So what that's done now is it's divided our circumference, right? And it's divided into 12 parts. We've only drawn half, so we've only got 6 parts, right? But yeah, I can, you know, I guarantee you that the other 6 are exactly the same as that. Now, what we're going to do is we're going to set these dividers. Okay, what I'm going to do is now, I'm going to just check that these are the same. Just a quick check, because we don't want to be, yeah, and that's pretty good, see. We don't want to be too far out, because we're stepping out 12 times. So potentially, you know, if we're a millimetre out on each one, we're going to gain over 12 divisions, we're going to gain 12 mil. And 12 mil on our circumference, you know, is going to be like 4 mil on our diameter, which is well outside any tolerances at this sort of size. What I'm going to do now Is that, no, tell you what I will do. I won't do that. And the reason I'm not going to do that is because I should really be showing you good practice, right? And what we should do for good practice is we need to number these points. Yeah. So I always like to start 0 on my seam. It makes the actual, when you actually come to cut the pattern or the, you know, transfer to plate, it makes it easier, you know, because you can start at an edge and, you know, you're going to know that's where your seam is. So for instance, we're going to have the seam there. It's going to run dead center. So I'm going to start at 0 and then I'm going to go right and I'm going to 1, 2, 3. Yeah. And what I'm going to do is I'm going to come back, right? Because technically I should go the whole diameter with my way round. Yeah. So 0 would be also be 12. I'm not going to do that. There's no need to do it because in fact we could get away with a quarter pattern on this because it's symmetrical in every direction. Yeah. When you're on the plan view. So I'm going to come back down this way. Go 4, 5, 6. Yeah. And I'm going to go 7, 8, 9, and I'm going to go 10, 11, 12. And the reason I did that is that it doesn't really, when you're developing this, using this method, it doesn't really matter. I know I split that into 12, so then I know I need to set this out 12 times. Yeah? 2, 3, 4, 5, 6. I always like to mark my centre or the middle of my pattern. If you're making it out of a heavier plate where you've got you can't roll it, you've got to press it incrementally. It's always good to know where your centre is because obviously you know your centre gets pressed last, especially on something this sort of size because of the way it fits in the tooling. Okay, so I always like to mark that centre line. Obviously we mark all these lines through, but I want to be able to spot my centre, you know, pretty easily. Okay, so we're going to go 7, 8, 9, 10, 11, 12. Right, now from our 8 backs to our 12th division, and scribe across. Now where I numbered them earlier, this point will be 0, 1, 2, 3, 4, 5, 6, so centre, 7, 8, 9, 10, 11 and 12. Okay, and like I said, it's not particularly important when you're doing this method. When we come to change this to a different method, numbering is really important, so you need to get into the habit of doing it regular. Okay, so basically there we go. This area here there can then be cut out, transferred to plate, and that's your pattern. Alright. Now bear in mind now there's no allowances here for material thicknesses, and it's a right angle cone, it's square, so that, you know, there's not a great deal to it, but it's pretty quick, very easy to do on site. Yeah, so that's that method. Now I mean with this stuff now we can cut this out if we want, we can take the plate, we can transfer it to the plate, job done. Right, okay, so the next thing we're going to have a look at is lobster back bends or segmented bends. Now there's a variety of methods to do a lobster back bend. For this we're going to assume that it's a standard 90-degree bend. It can be any centre radius, the centre radius doesn't matter. And we're going to assume that again, we're not going to add any material allowances for material thicknesses or anything like that. Obviously, when we do the dragon's tail, we're going to be allowing, because it's going to fit slightly differently. So again, I think we'll use this bit because we got a nice 4-inch pipe or whatever. And what we're going to do is we're just going to pick a centre radius. Like I said, it doesn't matter. It really doesn't matter. You know, just for this purpose. So I think, let's see how much line I've got. Here we are. I'm going to pick 300. Right? 300 centre radius. So I'm going to mark a point there at 300. So that distance to there is 300. If I was to swing an arc from that point there, from the centre, that gives me a centre radius of 300. Generally, we always work in centre radiuses. Obviously, the throat radius and the back radius would follow that. Right? So we've got that. That's our centre radius. Now, the way that everybody is taught, or the way that I was taught to do it now, would be I would scribe out my bend. Yeah. Then I divide it into however many segments that I wanted, and then from that, then I would draw a centre line up through my segment. Then I would take points. You know, I would draw my diameters, then divide it up very similarly to what we did with this. We divide it up, and that would give us dimensions to work with. When I was apprentice, somebody showed me a very, very quick method of doing it. Now, I'm not exactly sure how this works, right? But what I do know is that it does work, and it's certainly accurate enough for this type of thing. It's certainly accurate enough to create a pattern to wrap around a pipe, to cut a piece of pipe into a segmented bend on site, you know. So if there's anybody out there who can actually do the maths behind it, I assume it's probably very simple. It's just trigonometry, but if anybody wants to chuck something up in the comments or email me and let me know why this works, please do so. Right, so next thing we need to choose is how many segments we're having in our bend. So as a standard, it's usually 3. So we're going to go for 3 segments, a start and a finisher. Now, for every segment that we have, we're going to measure 100 mil from this point. Yeah, from the point of our centre radius. Yeah, for every starter that we have, so that's basically, the starter is half a segment, the finisher is half a segment. Yeah. For every starter we have, we're going to add 50 mil. For every finisher we have, we're going to add 50 mil. So we've got 3 segments, a starter and a finisher. Yeah. So that should be 400 mil. Yeah. 3 segments, 300 plus starter plus finisher. So what I'm going to do is I'm going to mark off 400 mil from that point that I swung my centre radius from. Yeah. So there is my 400 mil. What I'm going to do now, very inaccurately, what I really should do is bisect it and scribe a line up through it and whatnot. I'm not going to do that because for demonstration purposes, it doesn't need to be that accurate. What I'm going to do is I'm going to line my ruler, you know, across the baseline there, and I'm going to get it probably pretty good. Scribe a line. Right. Now, here's the interesting part. Any bend that's under 6 inches in diameter, I'm going to measure up 79 mil. My bend's over 6 inches, but under 12, I'm going to measure up 81 mil. Anything over 12, I'm going to use 82 mil. Right? So I'm going to go 79 mil from the baseline up to there. Here we go. Then I'm going to scribe a line from this point where I swung my centre radius from to the mark that I've just put on that line. There. Now what's happened now, as you can see, it's cut an angle basically through our diameter. Yeah? And what I'm going to do is just to continue the pattern, I'm going to set out my radius, and from anywhere on here, it doesn't matter, I'm happy to pick that point, but it doesn't matter, because all I need is 2 parallel lines. Yeah? Parallel to the centre line. So I'm going to join that up there with my join that to my angle that's cutting through there. There. One, line them up. And up. There. Okay, now straight away, now we're starting to form something that looks very much like half a segment. Yeah. Now, again, these are symmetrical, so we don't need to draw the other half. All the dimension that we need, we're going to get from this half, and basically just swing our dividers. We don't need the other half. Okay. Now, from this point now, what I'm going to do is I'm going to follow these lines up. Yeah, these divisions, and I follow them up through the plate. Now normally you can do it with a square, or I mean you can do it various ways. In fact, I'll tell you what I'll do. I'll do it a slightly different way. I'll scribe the other half of my diameter. Yeah, just to check these are right. Yeah. Okay. And I can mark them off on this side of the diameter as well. Okay. Just cross your centre line just to make sure you are. There we go. See your cock on now. Alright, I could have come all the way round. No, but I am going to start again this side. Mark them off. Alright. What we're going to do is going to join these points up. Yeah. So I'm going to come there. 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 And there we have it.